Hey y'all, so I wanted to help you out just a little bit with the analysis of our acrylic block lab, okay? Now, I understand that you could have gathered the data, you could just put it in a graph and you'd have a nice pretty little graph there. But one of the things I want you to learn from this graph is what does IB expect of you? And this is the same thing that any college level course would expect. If you did AP, they would expect the same thing. So this is not a weird IB thing, this is a science thing where they expect you to be able to linearize your data. They want you to be able to take your data and take it from whatever shape it is and turn it into a linear graph. So I'm not going to actually do it for any data here, but I'm going to explain to you how to do it. Okay? If you were to take the data from your acrylic glass lab, the refraction lab, and you were to put that into a graph, you probably would not get a straight line, okay? Because if you put your your angle of incidence on your x-axis and your angle of refraction on the y-axis, you will probably get some kind of curve, which that's good. It should be some kind of curve. You'll notice if you wrote down the equation that there are some trig functions in there. There should be some kind of curve between theta of incidence and theta of refraction. That's just the way it is. However, we want to be able to linearize it. We want to make it linear because when we linearize, we get slopes, we get y-intercepts, we get things that help us to find out other things about our data. All right? So what I want you to do is to look. This hopefully is the equation that you picked out. This is the equation that connects the angle of incidence and the angle of refraction. Now, in your data book, it looks like this. I'm going to change it so instead of 1, this is the angle of incidence. That's the angle at which the ray comes in from the air. And then angle 2 will be my angle of refraction. That's the angle that it goes at when it refracts through the glass. Now remember, the angle is the angle with respect to the normal. If you choose a different angle, this doesn't work anymore. So again, the 1 is going to be the I, the 2 is going to be the index of refraction inside the glass. Right? So 1 and 2 represent your different mediums. All right? Now, what you had is you had on your x-axis, your independent variable was the angle of incidence, and on the y-axis you had the angle of refraction. Now, what does that mean in terms of the linearization? Well, remember the whole point of linearization is that we want it to look like this. Y equals mx plus b, just like that. Now, in order to do that, we want the thing that is on the y-axis, that variable needs to be here by the y, and we need the thing on the x-axis to be here in the position of the x. So essentially, I need the index of refraction, the angle of refraction on this side, and then I need the angle of incidence on this side. Now, if they have squares or square roots or trig functions, that's fine. That can be there, but I need that variable physically on that side of the equation. All right? So one thing I'm going to do before I do that is to remind you that the index of refraction of air is approximately 1. So this in I is going to be 1. That's the index of refraction in the incident side when it's air. Okay? So that will be 1. Now, what you'll see is that we do have a fraction, and that's not going to be very helpful to the process that we're trying to accomplish here. So the first thing I'm going to do is try to get rid of that fraction. I also recognize that I want the theta I to be on the other side of the fraction. I don't want it with the theta R, right? The angle inside the acrylic. And so I'm just going to multiply both sides by sine of theta I, okay? Now, if I do that, what I'll get is on this side, the sine of theta I will cancel out, and I'll be left with sine of theta R, the angle of refraction, and that will be equal to 1 over an R times, because if I multiply this side by sine of theta I need to multiply this side by sine of theta I. And so that will be times the sine of theta I. Now, I haven't done anything weird yet. I've just rearranged the equation. So if you have any questions so far, please come check with me, because that's a math issue. That's not a physics issue. We've done no physics yet, right? I haven't even tried to connect it to y equals mx plus b yet. I've just taken the equation and rearranged it so that my angles are on other sides of the equation. Now, what you will notice is that the mathematics has actually done the work for us, right? We said that we wanted theta r to be on the y, and you'll see that right here. We said that we wanted theta I to be on the x, and you'll see that that is there. And the last thing, well, actually that's it. That's really what we wanted. Now, but what you will also notice is that the plus b is 0. That's pretty commonly the case. The slope will be 1 over the index of refraction in the acrylic, right? That's what the NR was, the index of refraction on the refracted side, okay? So what we need to do is, instead of putting theta I here, we want to put sine of theta I. So I'm going to graph sine of theta I there. And on the y-axis, I'm going to put sine of theta r, right? Now, you may say, but wait, how do I do that? Well, it's not that bad. You just take your theta i's, right? You're going to have a table that has theta I and theta r, right? You've already got that table made from your data points. And instead, whatever value here you have here, you just do the sine of that. Punch in your calculator. Make sure you're in degrees, because you probably measured your angle in degrees, not radians. And so you just make a new table, and you make this sine of theta I and sine of theta r. And so you take this number, and you go sine of that number, and that gives you sine of theta I. And then you take the next number, and you do sine of that, and that gives you this number. And you go for it, and you do that for each of them. Once you do that, you should be able to graph sine of theta I, these on the x-axis, and those on the y-axis. That should give you a straight line. The straight line will have a slope of 1 over nr. I hope that's helpful. If you have any questions, check with me in class.